Hello, and welcome to the VMware Data Center Virtualization Fundamentals e-learning course. This course will provide you with a fundamental understanding of VMware's data center virtualization products, including the business challenges those products are intended to solve. When taking this lesson, ensure that your speaker volume is on and at a comfortable level. You can use the navigation controls to move to the next screen of the course or to the previous screen. You also have the option to turn the audio on or off. In each screen, you'll find a Notes tab which you can click to display the full script of the audio track. The Menu tab lists all screen titles of all screens contained in the lesson. You can click on a screen title to move directly to that screen. This course incorporates a variety of instructional formats and resources, audio, interactions, and activities. Please make use of all of these resources, as they are designed to help you reinforce the important learning objectives of the lesson. There are 3 modules in this course. We'll start by introducing the concepts of data center virtualization, including some common IT challenges faced by organizations. In Module 2, we take a journey through the vSphere 5.5 product line, showing the various components and features and how they can help resolve business and technical challenges. Finally, in Module 3, we wrap things up by helping you relate the products and features to the challenges they are intended to resolve. At the end of this course, you should be able to define and describe the need for data center virtualization, provide an overview of the features of vSphere 5.5, and define how VMware's products help solve business and technical challenges with regard to data center virtualization. This is Module 1, Introduction to Data Center Virtualization with VMware vSphere. In this module, we will define data center virtualization, provide examples of business and technical challenges, and finally, provide an overview of the vSphere product line. At the end of this module, you should be able to define and describe the need for data center virtualization and provide an overview of the challenges that vSphere is intended to resolve. What exactly is data center virtualization? From a technical perspective, it's the conversion of hardware devices into software resources. So let's put that into human terms. Think about your data center. You probably have a number of physical servers sitting in racks alongside other networking and storage devices. You may have many different types of servers because each server has its own operating system, applications, and data. They all have something in common, though. They consume power. Unfortunately, that's not the only thing they have in common. Physical devices that use power also give off heat that we need to get rid of by cooling the data center. This too takes power, and power costs money. If we could figure out a means to break that cycle, we could save you money. Virtualization breaks that cycle. Now let's go back to the technical explanation. Virtualization converts hardware devices into software resources. That means that we can separate the server's operating system and applications from the underlying hardware by presenting virtual hardware that does the same job. The virtual hardware is actually just software running within something called a hypervisor. We'll talk more about hypervisors in Module 2, but for now, you can think of the hypervisor as a resource traffic cop. Its job is to provide each virtual machine with access to the underlying physical resources. This enables multiple virtual machines to share access to the same hardware without even being aware of each other. That leads us to one of the important advantages of virtualization: consolidation. Through virtualization, we can consolidate our servers into fewer pieces of hardware. By reducing the number of physical devices in the data center, we can save money on power and cooling, but we can also save money on capital expenses and management costs. Please select the advantages of data center virtualization. When you are finished, press Submit. Today, more than ever, IT departments around the world are being pressured to reduce their costs, while at the same time improving system availability and agility. This often poses some unique challenges for the organization, because cost reductions are usually at odds with these system-wide improvements. We have organized some of these challenges into 4 categories: availability, scalability, optimization, and management. Let's take a moment to explore some of these challenges from the perspective of both small businesses as well as large enterprises. To help put this into perspective, we'll look at these challenges through the eyes of 2 organizations. Though your organization may differ in size, you may find many similarities with respect to the challenges they are facing. Let's talk to one of the organizations now. Meet John from Sample Company 1. He is in charge of the IT operations for his organization and is going to share with us some of the challenges his organization is facing. Sample Company 1 is considering data center virtualization, but we need to help John figure out which products and features will help it the most. Let's see what Sample Company 1 has to say about its availability challenges. Drag the microphone to the image to hear about the challenges.
We need to minimize the downtime caused by hardware failures.
We have an application that must not be interrupted by hardware failures.
We need the ability to perform hardware maintenance during normal business hours, and we want to avoid taking down multiple servers simultaneously for patches.
Our server backups are difficult to test, and they don't give us the ability to easily restore an entire server.
We would like to replicate our servers to another site, but we need a hardware-independent solution.
Drag the microphone to the image to hear about the challenges.
We plan to purchase a new enterprise application that requires multiple dedicated servers, and it has the likelihood of expanding into many more servers in a short time frame. We need the ability to scale quickly.
We are interested in virtualization, but we don't have a shared storage infrastructure.
Drag the microphone to the image to hear about the challenges.
We'd like to know if we have performance-based bottlenecks, but our current hardware solution isn't able to provide that level of detail in its monitoring and reporting system.
We have several servers that have very large disk drives, but most of the space is empty. We would like to make use of this space more efficiently.
Drag the microphone to the image to hear about the challenges.
We have a number of physical servers that are running on hardware which is out of date and unsupported. We still need the servers, but we're concerned about reinstalling the applications on a new system.
I'm a one-person IT team, and I need a centralized and simple means to manage my environment.
Meet Dawn from Sample Company 2. As the IT director for her organization, she is responsible for coordinating and managing the various facets of its information systems. Dawn has arranged for us to interview several members of her staff, including the systems, storage, and network administrators. Sample Company 2 is considering data center virtualization to help with its growth and management challenges, but we need to help the company determine which products and features will help the most. Let's see what Sample Company 2 has to say about its availability challenges. Drag the microphone to the image to hear about the challenges.
We have a very aggressive service level agreement for our servers.
We want to perform our hardware updates during the normal business hours, but we don't want to impact our applications.
We need to automate or greatly simplify the execution of our disaster recovery plan, and we would like a means to non-disruptively test the plan during normal business hours.
Drag the microphone to the image to hear about the challenges.
Many of our servers are so heavily packed with different applications that we need a cost-effective way to scale out to additional servers for better application isolation.
Occasionally, we need the ability to add more CPUs and memory to our servers without incurring downtime.
We have a number of branch offices that are interested in virtualization, but they don't have a shared storage infrastructure.
We plan to add virtual machines regularly over time, We need an automated system to track and correct hotspots on our ESXi hosts and storage arrays.
Drag the microphone to the image to hear about the challenges.
We need detailed performance reports and proactive notifications to help us identify trending and immediate performance problems.
We're not using our storage effectively or efficiently. Not all of our virtual machines require high-performance storage. We need an automatic way to map servers to their appropriate storage class.
We have a lot of servers that aren't very resource-intensive. We plan to consolidate them as virtual machines, but we're concerned about the impact on our performance if we over or under-provision the hosts.
Drag the microphone to the image to hear about the challenges.
Our data center is too full, and we must find a way to reduce our power and cooling requirements, or we'll never be able to upgrade again.
Our server environment is complex and decentralized. We need a central management solution that will help us to keep track of everything worldwide.
We are a publicly traded company and therefore subject to a number of regulatory bodies. We need a solution to help us monitor our environment for unexpected changes.
As we've just seen, there are a variety of challenges in the IT world, and VMware vSphere is uniquely positioned to help solve challenges in each of these areas. Here are some of the features of vSphere that you will learn about next. Again, in Module 2, we'll explore these features in more detail to see exactly how they solve our data center problems. Now that you have completed this module, you should be able to define and describe the need for data center virtualization and provide an overview of the challenges that vSphere is intended to resolve. Click Next to continue to Module 2. This is Module 2, Components of VMware vSphere. In this module, we will explain what vSphere is and how its components support data center virtualization. You'll learn about virtual machines, the ESXi hypervisor, vCenter and its features, storage and virtual networking, vCenter Operations Manager, vCenter Configuration Manager, and vCenter Site Recovery Manager. At the end of this module, you should be able to discuss the features of VMware vSphere and provide an overview of the challenges that vSphere is intended to resolve. Before we talk about data center virtualization, we need to explain the core of virtualization, the virtual machine. From the outside, virtual machines look and behave just like physical servers. In fact, it may be difficult for your users to distinguish a virtual machine from a physical server, but there are some subtle differences that make them unique and very helpful in the data center. First, as we discussed in Module 1, the hardware of a virtual machine is really just software. While your users may not care much about this feature, it gives you a number of advantages, such as the ability to replace and upgrade components of the virtual hardware on the fly. Virtual hardware also allows you to add new hardware devices such as network cards and processors without rebooting the virtual machine. Ultimately, virtual hardware can help reduce your downtime because you don't need to reboot your virtual machines every time you wish to upgrade their capabilities. But virtual machines are also very familiar. Just like a physical server, each virtual machine has its own operating system and dedicated hardware. In this case, we're talking about virtual hardware, so you're not going to use up any additional space in your data center. Dedicated virtual hardware also means that virtual machines are just as stable and dependable as their physical counterparts. In addition, because the virtual hardware is designed to behave exactly the same way as physical hardware, there is no need to modify the operating system to support virtualization. This is important because you won't be introducing any special changes to the operating system that may affect the virtual machine stability. Finally, we should also point out that you, as the administrator, are in complete control of the virtual machines and their hardware. You install the operating system and applications in virtual machines much in the same way you would install these programs on a physical server. You can use CD-ROMs or even ISO images. Through the vSphere web client, you can remotely control the virtual machine, install software, and even perform more advanced operations such as cloning and snapshots. But what can we do with these virtual machines? As we've said, in most cases, a virtual machine behaves just like a physical machine. Virtual machines can be used to host any application from file servers, database servers, email servers, and even high-performance application servers. Organizations choose to virtualize their servers for a number of reasons. Some companies are interested in consolidating lightly used servers to conserve space and power in their data center. These workloads are ideal for virtualization because you can often place many virtual machines on a single physical host. Other times, organizations look at virtualization as a means to increase their availability, whether as a protection scheme against common hardware failures or complete site-level disasters. Virtual machines are easy to move, copy, and restore, so they make disaster recovery very simple. Still, other organizations look to virtualization as a means to provision new servers quickly because it is possible to create and deploy new virtual machines in just minutes. Whatever your reason for using virtualization, understand that virtualization doesn't hinder your performance. It enhances your capabilities. Let's discuss some of the superpowers that virtual machines possess. We said that virtual machines and physical machines are very similar, but there are some differences. For example, your virtual machines can do things that physical machines cannot accomplish. Think about the last time you applied a patch to a server, only to find out that it caused data loss or some other system instability. In the physical world, this results in upset managers and lost evenings and weekends for you while recovering the server from a backup. This dilemma can be avoided in the virtual world with just a few clicks of the mouse. A feature called Snapshots allows you to capture the entire running state of a virtual machine, from the contents of its hard disks to the state of its CPU and memory. Snapshots are fast and easy to use. If a patch or update does something unexpected, you can easily revert back to that point in time without the massive time investment of a full system restore. That's something most of us only wish our physical servers could do. Now, snapshots are a great tool that can help you get out of a bad situation, but they really aren't designed to be used as daily backups. Instead, virtual machines have another great feature that makes their physical counterparts pale in comparison. Using a technique very similar to the snapshot, you can take a complete image-based backup of a virtual machine while it's running. In the physical world, we call this a bare metal backup because it allows you to restore the entire server without the need to load a recovery operating system or perform file-by-file restores. Any virtual machine can be protected in this way, and it saves time and money during restores. Plus, you can still restore individual files. Part of the reason that virtual machines are so easy to back up and restore is because they are built on virtual hardware. In the physical world, when restoring a system, you typically need to find an exact hardware match. That can be very challenging during a disaster recovery operation when you may not even know the exact type of server hardware you had. Virtual machines have little to no dependency on the physical hardware, so you are free to restore them to a device of your choosing. This also makes testing your disaster recovery plan much simpler. So whether you are backing up or backing out of a problem, virtual machines are able to help. But what about the day-to-day requests for more memory or more disk space? Virtual machines allow for the hot add of virtual hardware, which means that if your virtual machine's operating system supports this, you can increase the capabilities of a virtual machine without restarting it. Think about that the next time you have to schedule maintenance on a weekend so that you can add a processor to one of your servers. These features aren't just technical advantages. They directly support your ability to help the business to remain more agile. By simplifying the backup and recovery processes, you can assure management that your disaster recovery plan isn't just for show. You can actually prove that it works without affecting your production systems. In addition, you can find real cost savings from the way in which virtual machines can be easily consolidated. For instance, you may wish to have two data centers, one with a low consolidation ratio to achieve maximum performance, and a disaster recovery data center where you are more focused on keeping things running than on performance. Now that we've talked about how virtual machines can help you, you'd probably like to know how they work and where they run. Let's take a look. Type the correct answer in the text box provided and click the Submit button. The correct answer is option 2. Click Next when you're ready to continue. Think back to our discussion about virtual hardware. What provided the virtual hardware? It was the hypervisor. The hypervisor is a resource traffic cop of sorts. Its job is to provide virtual machines with their virtual hardware as well as provide the appropriate share of physical resources to the virtual machine as defined by you, the virtual machine's administrator. That's right, you control how each virtual machine will perform by defining how much of a given resource will be allocated to the virtual machine. The hypervisor then executes based on your instructions. You don't have to worry about it being overly complicated. We have taken care of much of the management through a program you'll learn about soon, vCenter Server. For now, let's talk about the different types of hypervisor and what they do. There are two types of hypervisor, bare metal and hosted. The Type 1 hypervisors are called bare metal because they are installed on a physical device without an operating system. The bare metal hypervisors perform the functions of the operating system as well as the resource management features. VMware's ESXi is an example of a Type 1 hypervisor. On the other side, we have Type 2 hypervisors. These hypervisors are called hosted because they operate as an application on top of a pre-existing operating system. This separation of roles can be helpful if the underlying hardware isn't supported by a Type 1 hypervisor. VMware Workstation is an example of a Type 2 hypervisor. There are pros and cons to each hypervisor type. However, data center virtualization is typically performed using Type 1 hypervisors because there is less dependency on another operating system. There is also less resource overhead because the Type 1 hypervisor can perform both roles in a single piece of software. Let's take a look at VMware's ESXi hypervisor. As we've said, ESXi is VMware's Type 1 hypervisor. It's a bare metal hypervisor, which means that it performs the role of resource management while enjoying direct access to the underlying physical hardware. This can improve your resource efficiency because there is less operating system overhead. In addition, the stability of the ESXi hypervisor isn't dependent on another operating system. ESXi is commonly installed directly on hard drives in your physical server, but it can also be installed onto flash drives, SD cards, and USB drives. You can also network boot an ESXi host using traditional boot from network tools, such as PXE and TFTP servers. VMware provides a number of ways for you to deploy your ESXi hosts because each organization's needs vary. ESXi hosts your virtual machines and provides some basic management functions to help you deploy and control your virtual machines. Let's see what it can do. Build a Type 1 hypervisor. Click and drag each element to its correct position on the screen. When you're finished, click Submit. While virtualization is advanced, we still need your input to make it a success. Virtual machines are just servers. It is up to you to install the operating system, applications, and data files. Through your ESXi hosts, you can create new virtual machines, adjust their configuration files, monitor performance, and even control the virtual machine's operating system remotely. This works out well if you only have a single ESXi host, but as you add more hosts, things start becoming more complex. Now you have multiple consoles to open and multiple servers to manage. Plus, with only a single ESXi host, your management options are limited. To really take advantage of the advanced features of virtualization, you need a central management solution that can manage all your ESXi hosts in a single view. For that, you need vCenter. If you have a lot of virtual machines and hosts, you can have your hands full quickly. Fortunately, VMware has a solution for that. vCenter Server is an advanced management suite that provides tools and features that make virtualization a natural extension of data center management. Whether you have 1 or 100 ESXi hosts, you can leverage the user-friendly web-based interface to manage your virtual machines from a single point of control. vCenter isn't just for the large enterprise. vCenter Server is a multi-tier application designed with the enterprise in mind, but capable of managing even the smallest of organizations. We've engineered vCenter to be highly scalable so that it can grow with your data center virtualization initiatives. It includes components for an identity management server, database server, application server, web server, and vSphere web client. Although it may sound like a lot to manage, vCenter is simple to manage. You can deploy it in a variety of forms, giving you the ability to install the roles onto a single server or multiple servers depending on your needs. Plus, vCenter can be installed on a Windows system or deployed as a virtual appliance to give you even more flexibility. vCenter is designed to grow with you. For example, a single vCenter server can scale from managing a single ESXi host all the way up to 1,000 ESXi hosts. It can also manage up to 10,000 powered-on virtual machines. That is just one vCenter instance. As you grow, you can add more vCenter instances and even migrate into a cloud-based configuration to provide more management and provisioning abilities. In this course, you will learn about many features that vCenter provides. Let's take a moment to review them. Because vCenter manages each of your ESXi hosts, it has the ability to perform operations that require multiple ESXi hosts. For example, vMotion gives you the ability to migrate running virtual machines from one ESXi host to another without disrupting the virtual machine. Distributed Resource Scheduler, or DRS, provides load balancing for your virtual machines across the ESXi hosts. DRS leverages vMotion to balance these workloads, and if configured, Distributed Power Management, or DPM, can be used to actually power off unused ESXi hosts in your environment. Of course, it also can power them back on when the time is right. Storage vMotion allows you to migrate a running virtual machine's hard disks from one storage device to another, while Storage DRS automates the load balancing from a storage perspective. vSphere Data Protection gives you the ability to back up your virtual machines. vSphere also has availability features, such as High Availability, HA, to restart your virtual machines on another host if you have a hardware problem. If a virtual machine restart is too much downtime, Fault Tolerance, FT, provides uninterrupted availability for your virtual machines. And finally, vSphere Replication can copy your virtual machines to another site for disaster recovery purposes. As you can see, vCenter has a suite of features. Let's explore these features in more detail to see how they can help you. Have you ever wanted to perform hardware maintenance during the day, but you were told that downtime just wasn't acceptable? VMware has a solution for that: vMotion. vMotion allows you to migrate a running virtual machine from one ESXi host to another, even during normal business hours. The business implications for this technology are huge. You can think of this feature as a sort of proactive high availability. because you can actually evacuate an ESXi host before it goes down. Plus, as you'll see, you can use vMotion to help load balance your ESXi hosts in a cluster. vMotion gives you the freedom to make those hardware adjustments and updates during the business day because you can evacuate the virtual machines to other servers. But how does it work? vMotion is a migration process. As you've learned, virtual machines are built on virtual hardware, and therefore they are a little more tolerant than physical servers when it comes to swapping out pieces of hardware. Plus, a virtual machine is mainly a large chunk of memory on an ESXi host. That means you just need to find a means to copy that memory from one ESXi host to another. In simple terms, vCenter Server steps in and orchestrates the copy process between the ESXi hosts. The memory is copied between the hosts and the virtual machine is transferred to the new host. In most cases, you won't even notice a dropped packet on the network thanks to the way the ESXi hosts communicate with your physical network switches. It's extremely fault-tolerant as well. If anything were to go wrong, the original host remains in control and your virtual machine is unaffected. You should also know that vMotion can operate without shared storage, meaning that you can migrate a running virtual machine between hosts, even if the ESXi hosts have no shared storage in common. So vMotion is a pretty interesting and incredible technology. If only we could somehow use this to automatically balance our server loads. You can also automate vMotion. In fact, VMware has been doing it for years through a vCenter feature called Distributed Resource Scheduler, or DRS. DRS is a service within vCenter Server that monitors the memory and CPU load on your ESXi hosts. Over time, your ESXi hosts may become unevenly burdened. You might power on more virtual machines on one host than another, or you might have some virtual machines that consume more resources than others. If these virtual machines are all co-located on the same host, you could end up with a hotspot that could impact or limit your virtual machine's performance. DRS helps by gathering information on performance so that you can make better decisions on where to place your virtual machines. When you power on your virtual machines, DRS can tell you which hosts are better suited for the new workload. But it doesn't stop there. If you want a higher degree of automation, you can turn over control to DRS and let it use vMotion to balance your virtual machines across the ESXi hosts. So if one host becomes overloaded, DRS can step in and migrate some virtual machines to another ESXi host, and it can do this without bothering you. Just how smart is DRS? For example, what if you have a couple of servers that really shouldn't be placed on the same physical server? Perhaps they are part of a redundant cluster and really need to be isolated from one another. DRS can help you. One of the most helpful functions of DRS is its ability to maintain rules that match your business objectives. You can create a rule that binds multiple virtual machines together, or that forces them apart. These constraints are evaluated and enforced based on your configuration settings. You can even require that a particular virtual machine must run on a specific ESXi host. That can be very useful if you have hardware-based licensing. DRS provides a number of possibilities. But let's not stop there. Let's see how you can use DRS to save some real money. Think about your data center for a moment. You probably have peak and non-peak times. Perhaps it's the weekend. Whatever the case, your virtual machines are in low demand. Their CPUs are nearly idle, yet your ESXi hosts remain at nearly full power. What if you could somehow stack these idle virtual machines together on a fewer number of ESXi hosts until the demand increases? You could shut down the extra hosts and save some considerable power and money. That's where the next vCenter feature comes into play. Distributed Power Management, or DPM, leverages the automation of DRS to consolidate your virtual machines onto fewer hosts during non-peak times. It monitors the utilization of the ESXi hosts, waiting for periods of low activity. If your thresholds are met, DPM will activate and begin consolidating your virtual machines. After the host has been evacuated, DPM steps in again to power it off. That's the easy part. The next part is a bit trickier because we're going to power on a server that's actually powered off. To perform this function, You can use the traditional wake on LAN methods or the newer IPMI controls. Whatever your choice, when the demand on your virtual machines increases, DPM will initiate the power on request and bring the ESXi host back online to service virtual machines. As it brings new hosts back online, DPM leverages DRS to rebalance the virtual machines across the ESXi hosts. The end result is a system that can save money by actively powering off lightly used segments, while at the same time being mindful of your performance requirements. Everything we've talked about so far has revolved around CPU and memory performance. What about storage? Here is a situation that might be familiar to you. You want to perform maintenance during the day, but you're not allowed to take the downtime. But this time, we're not talking about servers. We're talking about storage devices. VMware has a solution that will let you move a virtual machine's hard drives from one storage device to another while it's running. That vCenter feature is called Storage vMotion. Storage vMotion gives you the flexibility to perform intrusive testing and maintenance on your storage devices during the day or whenever it's convenient for you. Scheduling a complete shutdown of a storage device is usually far more complex than shutting down a single ESXi host, so Storage vMotion is a tool that can deliver outstanding results. You can also leverage Storage vMotion when you upgrade your storage arrays. By configuring the ESXi hosts to see both the new and old storage arrays, you can non-disruptively move the virtual machines from one array to another in the middle of the day. Storage vMotion isn't limited to a particular type of storage. You can migrate from any supported storage type to another, including local storage devices. Using Storage vMotion, you could even move a virtual machine from a shared storage device down to a local storage device on an ESXi host. This is a great use for your local storage because it gives you the ability to service your large shared storage arrays without disrupting your production virtual machines. So, again, like vMotion, this is a useful tool, but surely there must be a way we can automate this. All servers use storage to some degree, but they don't all use it in the same way. What if you could monitor the storage habits of your virtual machines so that you could keep your storage devices more evenly loaded? Thanks to the vCenter server feature called Storage DRS, you can do just that. Storage DRS, like DRS, is a load balancer. However, Storage DRS focuses on your storage devices. It monitors the disk I/O on your shared storage devices to determine if a particular disk device is overburdened or becoming too full. You group the storage devices into clusters as with ESXi hosts, and then let Storage DRS spread the load as needed to keep everything performing as smoothly as possible. Like DRS, Storage DRS comes with different automation levels. You can just take the advice of Storage DRS and move things around manually, or automate Storage DRS and allow it to use Storage vMotion to make the necessary changes during normal operation. Storage DRS does a great job of keeping things balanced. But what if you have a couple of virtual machines that don't integrate well with others? For example, virtual machines that consume every drop of storage performance on your storage array, often at the expense of the other virtual machines on that storage array. These busy servers could be your large database servers, or even email servers. The busier they get, the more disk I/O they consume. Sometimes, they will actually consume so much disk I/O that other virtual machines barely get any time on the storage array. That's when your virtual machines all start to run a little slowly, and you must investigate the cause. Storage performance is very important to virtualization because your virtual machines typically share the same storage devices. If one uses a disproportionate share, every other machine feels the effects. What we need is a way to control the busy virtual machines so that they leave a little room for your other virtual machines. vCenter Server provides you with another useful feature called Storage I/O Control that does exactly that. You can control the busy virtual machines so that your other virtual machines can still get an appropriate amount of storage performance. This keeps all your virtual machines performing at a normal level, so you don't get called to investigate troublesome performance issues. Let's change the topic for a moment and talk about data protection. specifically your virtual machine's data protection. Unfortunately, virtualizing a server doesn't protect it from every possible occurrence. You can accidentally delete files in a virtual machine just as easily as you can do it in a physical server. Accidents happen. Fortunately, we're going to make backups much easier for you to create and use. Think back to our earlier discussion about virtual machines. We said that one of the superpowers your virtual machines possesses is the image-based backup. In the physical world, this is called a bare metal backup because it means restoring the server without the need to load a recovery operating system. You just restore the entire image and power it on. Virtual machines work the same way. And it's easy to make image-based backups of a virtual machine. Plus, you can still easily restore individual files from that image-based backup. As a vSphere administrator, you have access to a number of backup tools. VMware provides a tool called vSphere Data Protection, or VDP, that helps you to back up your virtual machines. The software leverages data duplication to make your backup storage usage more efficient than ever. It also comes bundled with most editions of vCenter Server, and you can manage the whole process using the vSphere web client. But what if you already have a preferred backup software application? No problem. VMware released an open set of APIs, known as VADP, that allow third-party software vendors to create these image-based backups of your virtual machines, so it's very likely that your backup software already supports virtualization. Ask your vendor. Protecting the software is great, but what happens if the hardware dies? Have you ever been called into work in the middle of the night because a server failed without warning? VMware can help. vCenter Server provides a feature called High Availability, or HA, that monitors the status of your ESXi hosts, virtual machines, and critical applications so that you can sleep at night. Let's talk about how HA protects you against hardware failures. While vCenter is used to configure HA to avoid a single point of failure, the HA services do not rely on vCenter to operate and execute. Instead, each ESXi host participates in a monitoring relationship. When a host failure is detected, the cluster will direct the surviving ESXi hosts to restart the failed virtual machines. The virtual machines do crash during the hardware failure, but they are restarted typically within a minute or less. We also mentioned that HA can monitor your virtual machines. Inside each virtual machine, there is a special set of software and drivers that gives your virtual machine its superpowers. This service is constantly talking to the ESXi hosts so that HA knows the virtual machine is running properly. Should this connection fail, due to an operating system crash or other system instability, HA can restart the virtual machine for you. As with the other services, this feature is highly customizable, so you can match the configuration to your business objectives. But what if you need to have a particular application monitored? Perhaps the server stays online, but the application is prone to crashing without warning. HA can also help you there by leveraging part of VMware's Hyperic product suite. HA can monitor services and applications so that you don't get that unwelcome call in the middle of the night. High availability is very useful, but what if you have one of those servers that just can't be offline? Some applications don't tolerate unexpected reboots very well. They may crash and cause data loss or corruption, or just not restart at all. Hopefully, you don't have many of these applications, but if you do, VMware has a solution for you. Another vCenter feature called Fault Tolerance, or FT, allows you to perpetually mirror your running virtual machine to another ESXi host. If one ESXi host crashes, your virtual machine continues to run on the other. It's a form of active-passive clustering that is completely transparent to your application. Another advantage of FT is that it is easy to configure. With just a few clicks of the mouse, your virtual machine begins to co-execute on another ESXi host and remains protected until you tell it otherwise. This works exceptionally well within a data center. But what about disaster recovery protection? Wouldn't it be nice if you could take a vacation and not worry about a data center disaster? Through the use of vSphere replication, VMware can help. vSphere replication allows you to copy your virtual machines to a remote site in your organization. This could be a disaster recovery site or just another office building. In fact, although vSphere replication is very useful for disaster recovery, you can also use it to centralize data within a large organization. You can have branch offices replicate their virtual machines to your corporate office for data protection and recovery. vSphere replication also allows you to recover from multiple points in time, just in case your most recent replication contained bad or missing data. In the event of a failure, you choose the point in time to recover, and then power up the replica virtual machine at the remote site. vSphere replication is also easy to set up through the vSphere web client. You control the replication interval and the number of point-in-time recoveries available at the remote site, and then let vCenter do the rest. You can also monitor the status of the replication so you know that it's working. Drag the vCenter feature on the left to the text on the right that best describes the feature's ability or purpose. When you're finished, click Submit to continue. Review the correct answers below. Click Next when you're ready to continue. Now let's change the topic again and talk about some of the things that make virtualization work. We explained that a virtual machine gets its CPU and memory from the ESXi host, but we haven't discussed storage or networking yet. In this section, we will explain the concepts of shared storage and where you store your virtual machines. We'll also explore the concepts of virtual networking and the different types of virtual network switches available to you. Let's take a look at shared storage. Think about your laptop or desktop computer and the storage inside it. Can another computer use that storage? If you said yes, you must have some sort of networking setup to make your storage shared. Shared storage doesn't have to be expensive. Most of us use shared storage every day. It simply means that multiple computers can access the files on the same storage device. In the virtual world, shared storage doesn't mean documents and images. It means virtual machines. If you want to host a virtual machine on different ESXi hosts, you typically need shared storage. In fact, many of the vCenter server features we discussed earlier require shared storage to operate. Let's take a look. Think back to our discussion on server failures. When the hardware failed, where were the virtual machines stored? If they were on local storage devices, the other hosts would not have been able to restart the virtual machines. Shared storage allows multiple ESXi hosts to access the storage even if one or more hosts become unavailable. Later you'll learn that even local storage devices can be shared using the right technologies. Here are some features that require a shared storage infrastructure to work properly. DRS, DPM, Storage DRS, High Availability, and Fault Tolerance. Let's see what you need to create a shared storage. Shared storage comes from a variety of technologies. vSphere supports Fiber Channel, Fiber Channel over Ethernet or FCOE, iSCSI, and NFS for shared storage. vSphere also supports local storage. While you aren't likely to use all of these technologies in a single ESXi host, it does give you the choice and the flexibility to adapt if your environment changes. Each storage option has its own strengths and weaknesses, and for this reason, VMware doesn't regard one storage type as better than another for virtualization. Let's consider local storage. What if you only have local storage, but you want those vCenter features we discussed earlier, like HA and DRS? Would you like to save some real money? Would you like the ability to use the shared storage features of vCenter without the cost and management of a full storage array? The vSphere Storage Appliance, or VSA, can help. VSA is a component of vSphere that allows you to create shared storage from the local storage devices in your ESXi hosts. It provides the management and control to share these local storage devices so that you can take advantage of features like DRS, HA, and fault tolerance. You designate disks within your ESXi hosts, and VSA takes care of the rest. And don't worry about a server crash. VSA will also intelligently replicate the data between the ESXi hosts so that if one server fails, you keep running. The VSA isn't just for small businesses. The need for cost-effective shared storage is also prevalent in enterprises. You can leverage VSA in your remote branch offices where virtualization would be helpful, but the added cost of storage management makes the prospect undesirable. Used in this way, you can centrally manage the various VSA installations throughout your organization from the vSphere web client. Remember how we said that not all virtual machines are created equally and that some need faster storage than others? Well, through a technology called vFlash, you can leverage internal SSD drives to accelerate the read performance of your virtual machines. This can also take some of the burden off your SAN, because vFlash operates like a read cache. To take advantage of this technology, you must install at least one SSD drive in your ESXi host, and then configure the virtual machine to use the vFlash storage. That leads us to our next point. Where exactly do we store virtual machines? All that you have just learned about storage is really in the background. Your virtual machines actually don't even know about the underlying storage devices. Your virtual machines believe they are using traditional SCSI hard disks, which is why they can be moved from storage device to storage device without interruption. In vSphere, the virtual machines are stored in containers called data stores. These are just logical volumes that allow you to organize the storage of your ESXi host and virtual machines. Think of a data store as a drive where you can store virtual machine files and ISO images. You can even browse the data stores to upload and download files within the vSphere web client. Although the virtual machines don't see the difference, there are two different types of data store: VMFS and NFS. The VMFS data stores are built on local, iSCSI, fiber channel, or FCOE storage, whereas the NFS data stores are built from connections to network-attached storage, or NAS devices. Both types of data stores support shared storage and all the vCenter features we discussed earlier. And now, as you can see, even storage uses networking. So let's explore virtual networking. We mentioned earlier in this course that virtual machines take advantage of virtual networking. It turns out that so do your ESXi hosts in vCenter. As you just learned in the storage section, your ESXi host can leverage storage technologies such as NFS, iSCSI, and FCOE, all of which rely on traditional Ethernet networking. In addition, your ESXi hosts are managed by the vCenter server and leverage the network for features such as vMotion, HA, and DRS. And finally, your virtual machines use the network to communicate with each other and the physical world. All of these things require something known as virtual networking. So let's explore what that means. Virtual networking is really very similar to physical networking. Each virtual machine and ESXi host on the network has an address and a virtual network card. Those virtual network cards are connected to virtual Ethernet switches. The only thing we're missing are the virtual cables. Why do we have to use virtual networking? Think about the rules of physical networking. Every device must have its own network card and address. If you had 20 or 30 virtual machines on your ESXi host, that would be a lot of network cards. In fact, you would have a challenge fitting that many network cards into a server today. Instead, VMware took a different approach. We know how to make hardware into software. That's what virtualization is all about. So why not create a virtual Ethernet switch in software? That's exactly what we did. Now let's see what these virtual switches can do. As we've said, VMware took the programming and logic of a physical Ethernet switch and turned it into a virtual device. It's very similar to how a virtual machine is built out of virtual motherboards, network cards, and storage controllers. It's just software that behaves like hardware. The rules of networking are still enforced. Virtual machines must have the proper addresses and protocols, but it can be done with a lot less cable mess. You can use these virtual switches to attach your virtual machines to the physical network, or you can create isolated networks to be used during testing and development. With virtual networking, you have the same flexibility that server virtualization provides. There are different types of virtual switches, and you can choose the one that best suits your business needs. Just like physical switches, virtual switches come in different forms, each with a different feature set. vSphere supports two main categories of virtual switch, the standard switch and the distributed switch. Both switches help you to reduce network clutter by reducing the number of physical network cables plugged into your ESXi hosts. Each ESXi host comes pre-built with a standard switch that provides basic connectivity and management features. The distributed switch expands upon that model by providing a central interface to manage the different connections and features found in the virtual switches. As a result, the distributed switch is able to provide more features as a result of this centralized management approach. Let's briefly talk about some of the features found in virtual switches. Virtual networking can be as simple or as complex as you need it to be. Here are some of the features supported by vSphere. VLANs provide logical separation of your network traffic and are often used to isolate different subnetworks, such as a test or a restore network. Traffic shaping is a feature that allows you to restrict the inbound and outbound network bandwidth of a group of virtual machines. This can help reduce congestion in your virtual network. Port mirroring gives you the ability to monitor a virtual machine's traffic for troubleshooting or intrusion prevention. It allows you to capture all the traffic sent to or from a virtual machine for later inspection. Quality of service, or QoS, and DSCP are networking standards that allow network switches to prioritize certain network traffic over others. For example, you may wish to prioritize the voice traffic from a call manager server to improve performance. NetFlow is a network monitoring tool that allows you to determine your top talkers on the network, as well as other metadata about the communications that occur on your network. CDP and LLDP are discovery protocols used to identify neighboring physical network switches. They can be used to help discover and help troubleshoot misconfigurations. Now that we've discussed the storage and networking aspects of virtualization, let's take a step back to see where all this fits into our discussion so far. Type the correct answer in the text box provided and click the Submit button. We've discussed a lot of vCenter features. You have learned that virtual machines gain their CPU and memory resources from ESXi hosts. You've also learned that the ESXi hosts leverage both virtual and physical networking to allow the virtual machines to communicate. And you've learned that the ESXi hosts manage the storage that the virtual machines use in such a way that the virtual machines are generally unaware of the underlying storage types. Finally, you've also learned about a number of vCenter features that make managing your virtual data center a much simpler process. This chart should help you to see how the features we've discussed align to the different editions of vSphere. You're almost there. But we have a few more topics to cover. Up until now, we focused on the vSphere and vCenter features that enable data center virtualization. While vSphere and vCenter truly provide a great platform for virtualization, some organizations can use a little more help. VMware has additional products such as vCenter Operations Manager, vCenter Configuration Manager, and vCenter Site Recovery Manager that enable you further to refine and manage your environment. Let's see how vCenter Operations Manager can help. In your organization, how do you know when you are having a problem? If you're like most people, you probably said, "When my phone rings." Wouldn't it be useful if you could get notified before the problem occurred? VMware makes this possible with a program that can monitor trends and look for risks and inefficiencies that could make your phone ring. That program is called vCenter Operations Manager. vCenter Operations Manager can help you to get a handle on performance, capacity, and efficiency issues. It works with vCenter Server to gather and consolidate the performance statistics into supermetrics. These supermetrics are summarized into the categories health, risk, and efficiency. Health represents immediate issues that need to be resolved or investigated. Risk represents issues that will affect capacity or performance in the future. Efficiency represents issues that involve right-sizing your virtual machine's disks, CPU, and memory. By collecting and summarizing these metrics, vCenter Operations Manager can save you countless hours sifting through thousands of statistics, comparing and contrasting values. Also, vCenter Operations Manager includes dynamically adjusting thresholds, which means that you get fewer false positives. By learning what your organization considers normal, vCenter Operations Manager can restrict its alerts to only include those that are out of the norm or that include actual errors. These analytics adjust over time and help you to detect problems before they become phone calls in the middle of the night. vCenter Operations Manager is able to monitor your current capacity so that you know when it will be time to expand your servers and storage infrastructure. This sort of forecast is extremely helpful when budgeting and planning because it can help you to determine when you'll be in the market for new equipment. You can change the criteria to play out some what-if scenarios based on your business objectives and direction. vCenter Operations Manager can then show you how your system will look under those circumstances. vCenter Operations Manager also comes in a number of editions, so you can choose the edition that is right for your organization. Now let's look at vCenter Configuration Manager. How often do you spend time troubleshooting issues when everyone says, "Nothing has changed," or "We didn't do anything"? In a complex environment, it can be challenging to determine who changed what and when. Moreover, even if you can identify what was changed, you still may not be certain what the configuration looked like before the change was made. Wouldn't it be useful to have a tool that could monitor your configuration, notify you when something changes, and then help you to correlate current problems to those changes? That is exactly what vCenter Configuration Manager does for you. vCenter Configuration Manager is tied into vCenter so that it can review and monitor changes that affect vCenter, your ESXi hosts, and your virtual machines. It can also integrate with vCenter Operations Manager to provide a holistic view of your environment. vCenter Configuration Manager is able to compare your configuration to third-party specifications for security hardening and regulatory compliance. The best part is that vCenter Configuration Manager is automated, and it can notify you when deviations occur. In many cases, it can even automatically enforce and remediate non-compliant configurations. By properly documenting, tracking, and enforcing configuration compliance, you may be able to cut out some of the politics that accompanies virtualizing your Tier 1 applications. vCenter Configuration Manager can help you to adhere to your vendor's requirements while also guaranteeing that if something is changed, you can correlate that change to current events easily. Finally, vCenter Configuration Manager is a very useful security tool because it enables you to systematically harden your environment and then audit that configuration on an ongoing basis to mitigate the risk of configuration drift and backdoors from becoming security threats. Speaking of protection against risk, let's look at how vCenter Site Recovery Manager can help mitigate the biggest threat, disasters. When was the last time you tested your disaster recovery plan? A complete test, the kind where you restore the servers and make sure that all the data is usable and all the applications work as expected. If you're like most companies, you may never have done this level of testing. Why? It's time-consuming and very challenging to coordinate the failover and failback of the servers and data. What if you could do this without the complications and frustrations? You can with vCenter Site Recovery Manager, or SRM. SRM is an orchestration tool for disaster recovery. Its job is to make your disaster recovery failover and testing simple and pain-free. You can replace your ever out-of-date disaster recovery runbooks with simple automated recovery plans. These plans capture the recovery process in a simple, centralized manner that gives you peace of mind during your testing and recovery. SRM is also able to perform frequent non-disruptive testing of the plan so that you can determine if your plan works before the disaster strikes. But also, when the disaster does come, even your CIO can initiate the automated SRM failover process. SRM can also be used for data center migrations. Because no two organizations are the same, SRM allows you to choose between protecting just a handful of virtual machines or your entire environment. Through the use of vSphere replication, SRM is able to replicate select virtual machines and even provide multiple points in time for recovery purposes. On the other hand, if you need to protect a number of virtual machines, SRM can work with your storage provider to coordinate the replication failover and testing processes. Now that you have completed this module, you should be able to discuss the features of VMware, vSphere, and provide an overview of the challenges that vSphere is intended to resolve. In the next module, we'll have a look at several case studies and see how the VMware products we just covered can resolve a wide array of IT problems. Click Next to continue to Module 3. This is Module 3, Applying What You Have Learned. In this module, you will apply what you have learned about data center virtualization to overcome availability, scalability, optimization, and management challenges for our friends that you met in Module 1. At the end of this module, you will be able to describe how VMware's products help overcome business and technical challenges with regard to data center virtualization. Let's take a moment to step back and review why we are learning about data center virtualization. Remember, the goal is to overcome challenges that businesses face in a number of areas, including availability, scalability, optimization, and management. vSphere encompasses solutions that help overcome many challenges. Next, we'll give you a chance to put your knowledge to the test. We will present you with the business and technical challenges you heard in Module 1. Then you will review and identify an appropriate solution based on what you learned in Module 2. The goal is to help you understand which features resolve a given challenge. Let's start by looking at availability challenges. Click on an image to find out VMware's product solution for each problem. When you're ready to proceed, click Next.
We have an application that must not be interrupted by hardware failures.
We need to minimize the downtime caused by hardware failures.
We need the ability to perform hardware maintenance during normal business hours, and we want to avoid taking down multiple servers simultaneously for patches.
Click on an image to find out VMware's product solution for each problem. When you're ready to proceed, click Next.
We would like to replicate our servers to another site, but we need a hardware-independent solution.
Our server backups are difficult to test, and they don't give us the ability to easily restore an entire server.
Drag and drop a product to solve a staff member's problem. When you're finished, press Submit, and we'll move on to discussing the scalability challenges. Type the correct answer in the text box provided and click the Submit button. Please review the correct answer below. When you're ready, click Next to continue. Have a look at another scenario and type the correct answer into the text box provided and click the Submit button. Click on a VMware product to hear how it has helped this company. When you're finished, click the Next button to move to the next slide, where we'll talk about optimization challenges.
Many of our servers are so heavily packed with different applications that installing one patch can take down multiple systems. Virtual machines are a more cost-effective way to scale out to additional servers so that we have better application isolation.
Occasionally, we need the ability to add more CPUs and memory to our servers without incurring downtime. Hot Add allows us to do this effectively.
We have a number of branch offices that are interested in virtualization, but they don't have a shared storage infrastructure. VSA solves this problem.
We plan to add virtual machines regularly over time. We were concerned about our hotspots on our ESXi host and/or storage arrays. We needed an automated system to track and correct this for us. DRS and Storage DRS allowed us to do this.
Click on an image to find out VMware's product solution for each problem. When you're ready to proceed, click Next.
We'd like to know if we have performance-based bottlenecks, but our current hardware solution isn't able to provide that level of detail in its monitoring and reporting system.
We have several servers that have very large disk drives, but most of the space is empty. We would like to make use of this space more efficiently.
Click on a VMware product to hear how it has helped this company. When you're finished, click the Next button to continue, where
We need detailed performance reports and proactive notifications to help us identify trending and immediate performance problems. VCOps allows this to happen.
We're not using our storage effectively or efficiently. Not all of our virtual machines require high-performance storage. We need an automatic way to map servers to their appropriate storage class. Virtual Machine Storage Profile solves this.
We have a lot of servers that aren't very resource-intensive. We plan to consolidate them as virtual machines, and VCOps eliminates our concern about the impact on our performance if we ever over or under provision the hosts.
We are interested in virtualization, but we were concerned about the network performance of our virtual machines. Distributed switches with QoS allows for a means to prioritize the network traffic of certain virtual machines.
drag and drop a product to solve a staff member's problem. When you're finished, click the Next button to continue. Click on an image to find out VMware's product solution for each problem. When you're ready to proceed, click Next.
Our data center is too full, and we must find a way to reduce our power and cooling requirements, or we'll never be able to upgrade again.
Our server environment is complex and decentralized. We need a central management solution that will help us keep track of everything worldwide.
We are a publicly traded company and therefore subject to a number of regulatory bodies. We need a solution to help us monitor our environment for unexpected changes.
We've learned that data center virtualization does a lot for organizations, but what does it do for you? Here are just a few things that come to mind. By saving money, you could be saving your job or someone else's. By improving your IT system's reaction time through the use of templates, clones, and proper disaster recovery, you make your team more valuable to the organization. By automating and optimizing your system, you will gain the kind of peace of mind that most IT people wish they had while on their vacations. Next, let's see where you can go with this new information. You've learned a lot about data center virtualization, but we haven't talked about how to actually implement it yet. To learn more, including how to implement these features and more, enroll today in the vSphere Install, Configure, Manage class. Afterwards, you'll be well on your way to your next certification, VCA-DCV. Now that you have completed this module, you should be able to identify which VMware products help solve business and technical challenges with regard to data center virtualization.